Welcome to Math 1314 Review and Practice, Week 12, Part 4. Log base 27 of 81. So we can use the method we practiced before in Part 2 and 3. Okay, and we have the definitions of the log. If we have log base b of a equals c, we can rewrite it equivalent to b. Look further, to the power c equal a. So let's say if I call this one is x at the answer, I will have 27 to the power of x equal 81. Base is 27, c is x, and then a is 81. We're looking at the positions as whole. So base is this positions, that is 27. The next position is a, that is 81, and then c is x. Okay, so we go b, go further to c, that's the exponent, equal a. So for 27, we know that we have base 3. So 27 is 3 times 3 is 9 times 3 is 27, so 3 cubed. And then we have 81 is 3 times 3 is 9 times 3 is 27 times 3 is 81. So 3 to the power of 4. Or you just kind of like make 3 times 3 is 9, 3 times 3 is 9, so you have 9 times 9, that's 9 squared. That also 81. So I would rewrite 27 at 3 cubed, all to the power of x, that equals 3 to the power of 4. Now we rewrite it 3 to the power of 3 times x, 3x equal 3 to the power of 4. Now we have the same base. The exponent will be the same, so 3x equals 4. Now we can solve for x by divide both sides by 3. So x equals 4 over 3. So because x equals 4 over 3, we can say log base 27 of 81 equal 4 over 3. By using the technique we already learned from part week 12, part 2 and 3. Log base 32 of 7 root of 16. So as we see 32 and 16, we know that we will use base 2 in common. Okay, so 32, that is 2 to the power of 5. Then 16 is half of it, so 2 to the power of 4. Okay, and remember we have root r of base a to the power p, that equal a to the power on the top over the root at the bottom. So 7 root 16, 16 is half the power of 1. So we will rewrite this one as 16 to the power of 1 over 7. And now for the 32, how can we working on it, because it's not the base, right? So we will use the chain of base formula. So as you notice that when you write down log base b at the bottom most, right? So of a, that equal log base c, you can choose any base c of a because a at the top, so it keep above, okay? The same base c will be used, and then b at the bottom. If I drawing it like this, you see this is like the line to right? This one behind the line, this one above, a is above the line. So log base c of a over log base c of b. That's how we remember it. Now we'll rewrite this one at log. I know that I will use base 2, so I write out 2. My c is 2. Of 7, I will write everything one more time so that it makes sense to you. Log base 2 of 32. Okay, so my a is 7 root 7 of 16. My b, that is 32, and then my c is 2. Okay, now I will rewrite one more time. I will have my log base 2, 7, 16, right? So I will write out 16, 1 over 7. Okay, over 32 is log base 2 of 2 to the power of 5. Now, instead of 16, I will write down 2 to the power of 4. Okay, that is my 16. So this one will be 2 to the power of 4 to the power of 1/7. Okay, now remember that we have a to the power of m to the power of n. That is the product of exponents, so m times n. Keep the base the same. So I have my 2 to the power of 4 to the power of 1/7. That is 2 to the power of 4 times 1/7. That is 2 to the power of 4 over 7. Okay, let's write that one more time. Log base 2 to 4 over 7 over log base 2 to the power of 5. Now we will apply the power rule right here. So you see that if you see the power, you can move it in the front. Okay, so this is my power, this is my powers. I can move it in the front. So I will have equal 4 out of 7 log base 2 of 2 over 5 log base 2 of 2. This is multiplications, okay? As you see, this is the multiplication. Okay, now you have log base 2 of 2 is just 1. Okay, log base b of b is 1. But we even don't care about that identity rule. But you see that log base 2 of 2 and log base 2 of 2, the same thing, you can cancel it. Now your problem is you have to simplify 4 over 7 divided by 5. Okay, and this one is 4 out of 7. When you divide at a fractions, you will multiply the opposite, the reciprocal of it. So 5 become 1 is multiplied by, okay, divide become the multiplication to 1 out of 5. So 4 over 7 divided by 5 is the same thing as 4 over 7 multiplied by 1/5. Okay, and then it's become 4 out of 7 times 5, 35. Okay, so for this question, always remember when you see just log A equals C, you always know that when you see the log by itself, the base is 10. Okay, this one the same thing as log base 10 of A equals C. And the power of 10, remembers how many zero make it the power. So 100, how many zeros you have? 2. So it will be 10 to the power of 2. 1000 is 3 zero, that is 10 to the power of 3. Okay, so this one is the same thing as we have the log base 10 of 10 square. Okay, now this one we have apply the power rule here, so we take the 2 in the front. All right, now the leftover is the log base 10 of 10. Now log base b of b, that identity rule set that would be equal 1, so it's equal 2 times 1, that equal 2. So basically later on when you see something like log of how many zero here, 1 2 3 4 5 6, is log 10 to the power of 6, and the answer is what? Is 6, just the exponent of the 10. Okay, that makes sense, because anyway when you move the 6 in front via the power rule, so you will have log base 10 of 10, which is mean log of 10, which is means is 1. So let's say we will have log 10 to the power of x, that is x. That's the formula. You can use x or a, b, but it has to be the same letter. Like log base 10 of a equal a. So just like this, the inverse property of log. See that? B to the power of x. In this case, the base is 10, but you can see log base 2 of 2 to the power of 10 is 10, because the 10 is matching that exponent. So this is the inverse property of logs. By using that, this one is easier, right? So we can 1 2 3 4 5 is 5. Done. How? Okay, so let's do it again. So we have log base 10. Remember, log is mean base 10. So 10 to the power of 5. Now this is base 10, so it's equal 5 based on the inverse property of log. But even if you don't know about that inverse property of log, you can use just the first 5 formula to solve for it, just like I explained it. So we have the log base 10 of 10 to the power of 5. We move it in the front because power rule we use. Okay, so we will have 5 log base 10 of 10. Now we use log base 10 of 10, we use identity rule, that is 1, so you have 5 times 1, that is 5. But if you know the inverse property of logs, then you just answer it as 5. Easy and quick. Now this one a little bit more complicated. Okay, so we're still counting, but 1 2 3 4, so we have 10 to the power of 4. Okay, and this is the log base 10. So remember, we can rewrite the root 3 of 10 to the power of 4, and the fractions in the exponent. So log by 10 of 10 to the power of 4 out of 3. Okay, power over the root is equal to 4 over 3. It's because of the inverse property of logs, or it's also combined of identity rule and power rule, like we just explained in the previous questions. So for this question, we have to rewrite 1 over 1000 equal 1 over 10 to the power of 3. We count 1, 2, 3, and remember we have 1 out of 8 to the power of n. It could be 8 to the power of negative n. So this one could be 10 to the power of negative 3. 8 is 10, n is 3. Okay, so we rewrite this one at log of 10 to the power of negative 3. Now the answer is negative 3. Alright, so this one is super easy, right? Because based on the inverse property of logs, this one, you have 8, it's the same base. Now the answer is just the exponent, equal 4.1. This is point. This is the decimal, not the multiplication. So this is this. Just like x right here, add x right here, the same thing. Or you can use the power rule and the identity rule to solve for it. We have log by a of 8. Remember, we have the power rule. We move the exponent in front and then do the multiplication. So 4.1 times the log by a of 8. And if you use the identity rule to apply for by 8, you will have 4.1 times 1. That is 4.1. Now, base is the square root of 7. So identity rule, what they say is equal 1. So you don't have to think. It's the same value, that is equal 1. The base in this case is square root of 7. Now for this one, you see that you have 90 here and then 90 here, but it's 1 over 90. So remember 1 over a to the power of n is a to the power of negative n. So we have 1 over 90. 90 is to the power of 1. Okay, it's always when you see a number, that is the power of 1. So when you rewrite it, you will have 90 to the power of negative 1. So if we rewrite it, we have log 90 of 90 to the power of negative 1. And now let's go back to the inverse property of logs. So the exponent is the answer. Okay, so this is the exponent, that is the answer. The exponent x is the answer. Or we can use the power rule to take the negative 1 in front, and then we use the identity rule to say log 90, base 90 of 90 is 1. So 1 times negative 1 is negative 1. Okay, so now we will use the change of base formula. Since we see the base is 7 right here, and we see 49 should be 7 square. So 5 root 5 of 49, that is root 5 of 7 square. And based on the formula, we can rewrite as 7 power on the top over the root 5. Okay, now it will be equal log base 7 of 7 to the power 2/5 out of log base 7 of 7. So the base right here is 7. And we always choose C equals 7 as well. Okay, B is 7. A is 5 root of 49. That is 7 to the power of 2/5. Okay, now we continue. This is 7 to the power of 1, right? We can use the identity rule to say log base 7 of 7 equal 1, but also we can use the power rule to say that is 1, because when you move that's 1 in front, then you will have 1 times 1, that is 1. Anyway, okay, so let's do the inverse property of logs. So we have this one, the same base 7, so the power will be the result. So we have 2 over 5 over 1. Anything over 1 is just that thing, so 2 over 5. So one more question similar to the previous one. So we have base 3, this is 9. So I can use the inverse property of log. It's log base 3. Now I'll rewrite the 13 root of 9. 9 is 3 square, and then we have 13 root. So we write down base is 3, power is 2, root is 13. So this is 3, 2 out of 13. Okay, so inverse property of log, this one, saying that the exponent will be the result, 2 out of 13. So we're looking at 125. I think after practice enough, we know this is 5 cubed. And then 25, that is 5 square. So I will use the chain of base, and I will choose my base C is 5. Okay, so this one would be log base 5 of 25, the above, over log base 5 of 125. And making sure when we write down the equal sign with the fraction, it have to be in the middle. Now we redraw it one more time. Log base 5 of 5 square over log base 5 of 5 cubed. Using the inverse property of log, the exponent is the result. So on the top we have 2, at the bottom you have 3. 2 out of 3. Or you can use the power rule and identity rule to solve for it. So multiply log base 5 of 5, multiply log base 5 of 5. This is gone. Then 2 out of 3. Same thing. So quicker is the inverse property of logs. Now we have 4 is base 2. So 4 is base 2, so 2 squared. 32 always remember is base 2 of 5, so 2 to the power of 5. Now one more time, log base 2 of 32 over log base 2 of 4. Now rewrite log base 2 of 2 to the power of 5, log base 2 to the power of 2. Now exponent, same base, so the answer will be 5 on the top, at the bottom is 2. Okay, so this is a time to redo number 30 by yourself. This one is the triple, it's the same thing, but after few seconds, I will start to do the new method. Ready? Let's review number 30 again. That we said we will kind of set this one at x, so we have 27 to the power of x equal 81 using the definitions of the log. Okay, and then we change the base of 3 to the power of 3, r to the power of x equal 3 to the power of 4. Then we set the exponent equal 3x equal 4, and then we solve for x equal 4 out of 3. That's what we do in number 30. But I want to introduce you a new method using the chain of base formula. Okay, so we can use, we know that base 3 still. We will write down log base 3 of 81 out of log base 3 of 27. Then we rewrite 81 at 3 to the power of 4. Out of log base 3, 27, rewrite at 3 to the power of 3. Now we use the inverse property of log. See, the exponent is the answer. So that would be equal 4 over 3. So you don't have to call the x like the first method. You just solve for it straightly, directly to the answer, to find the answer. So whichever way is still, you have to say on the first method at conclusions is 4 out of 3 because they don't have x, right? You just call them, so you have to have the conclusions of your result. But with the second method, we use the chain of base formula, then we just directly solve for it without calling the answer is x. So this one is similar but a little bit different. We will write down log 2781. We know we have to use base 3. How we know it? The more you're familiar with the numbers, then the more you know it. So making sure, remember 81, 27, that is base 3. 3 to the power of 4, 27, 3 to the power of 3. So I choose C in the formula here, the last one. The power C is the base, the new base is 3, C is 3, and then root 7, 81 is 7, okay, that is the root 7, 81 is 3 to the power of 4. Now power is 4 on the top, the root at the bottom, 4 out of 7, 3, 4 out of 7, and then at the bottom 3 to the power of 3. So remember, in our formula, this is the C we choose, this is A, this is B, this is B, this is A. See the position of it, and then plug in. Okay, now after that we use the inverse property of logs, and the exponent is the answer. So we have 4 over 7 over 3. It's come from the exponent here. Okay, now 4 over 7 divided by 3 means multiply by 1/3. 4 out of 21. Okay, so get what is the base we use for the change of base formula. What is C value? It could be 5. Why? Because you see here 5, here is 125. 5 is 5 to the power of 1. 125 is 5 to the power of 3. So we use log base 5, 125 here, 1 over 5 here. Now rewrite one more time, log base 5, 1 over 5, 1 over 5. The power here is 1, so we flip it. We have 5 to the power of -1. So 5 to the power of -1 out of log base 5. 125 is 5 to the power of 3. Now using the inverse property of log, okay, the first one, the second one to use, we're looking for the exponent, that is the answer, -1 out of 3. Okay, so this one we have the base is 1 over 81. It looks weird, but just look at this at B, look at this at A, then use the formula log. Remember 27 and 81? Common base is 3. So 27, 3 cubed. Okay, log base 3 of 1 out of 81. 1 out of 81 to the power of 1. No, we don't use it. We have to convert it first, okay? So it's 1 over 3 because our common base is 3. 3 to the power of 4. Okay, now flip. 3 to the power of -4. Okay, now so we use the inverse property of logs. Whatever the exponent is, that is the answer. Equal 3 out of -4. Thank you for participating in this series, and see you next time.